Hi, my name is Dr. Jonathan Fairman, and I'm the principal modeler behind Build Your Own Earth. What we're going to talk about today is a couple of climate properties and the results from the current day 2015 simulation. These are going to be the mean surface temperature, the jet streams, clouds, and precipitation. I'm going to try to walk you through how to interpret these from Build Your Own Earth output, so that you will be able to interpret further climate simulations for any assignments that you may have. Let's get started by going to Build Your Own Earth. Since we've taken the tour already, we're going to click Get Started. What we want to do is look at the recent Earths, current day 2015, and then select Atmosphere, Mean Temperature, and Surface. These should be the default variables selected. Let's click View Model to get our simulation results front and center. The viewer will default to looking at a slideshow of monthly average surface temperatures. Let's pause the slideshow and look at different months specifically. If we look at the mean temperature in January, there are numerous features that we should be able to interpret. For example, the mean surface temperature is coolest over the North Pole in January, and Siberia, where you have temperatures that are actually less than minus 40 degrees Celsius. It is warmest over the Australian outback, with average temperatures exceeding 30 degrees Celsius. If we look over the UK, we can see that it is generally warmer than other areas at the same latitude due to the impact of the Atlantic Ocean. And this is also true if we look at the west coast of the United States. There are large swaths of the Earth that have temperatures greater than 20 degrees Celsius, typically from around 20 degrees north to around 40 degrees south. If we scroll through to July, we can see that the temperature fields change quite a bit. Antarctica is now the coldest place in the world, with temperatures less than negative 50 degrees Celsius, whereas the warmest places in the world are in the Saharan Desert and Saudi Arabia. Average temperatures for the UK are between 10 and 15 degrees Celsius, which is a little bit below the actual average temperatures, which are generally around 16 degrees Celsius in Manchester and 19 degrees Celsius in London. If we let this scroll through the entire year, we can see how the areas of highest temperatures proceed from the south to the north over the northern hemisphere summer and proceed back down to the south during the southern hemisphere summer. Okay, so we're going to shift gears a little bit and look at the jet streams. These are regions of fast-moving winds aloft in the mid-latitudes of each hemisphere. In order to look at the jet streams, we're going to want to change our climate properties to atmosphere, mean winds, and then select our analysis level at 250 hectopascal. 250 hectopascal is around 10 to 11 kilometers above sea level. What we see when we look at this field is two areas of enhanced wind speed, one in the northern hemisphere and one in the southern hemisphere. If we pause this and scroll through some of the months, you'll notice that the northern hemisphere jet streams are strongest in December and January, where you have wind speeds exceeding 60 to 70 meters per second off the coast of Japan over the Pacific Ocean, and that they are the fastest in the southern hemisphere during June and July, where values over Australia also exceed 15 meters per second. The wind speeds in the jet stream are always going to be the highest in the winter hemisphere due to the strong temperature gradients between the tropics and the poles during those seasons. Another factor that we can examine is cloud fraction and rain for the model results. If we go to atmosphere and cloud fraction, and scroll through these again, the Earth is dominated by a feature that we call the intertropical convergence zone, a region of persistent clouds and precipitation in the tropics. If you look for the area in white here over the tropics, we can see that that area of high percentage of cloud cover moves from the south to the north over the course of the year. You can see that the cloudiest locations are usually in the tropics, so in September somewhere between 10 to 20 degrees north, and with areas that are the least cloudy just to the sides, so over here in the Sahara where there are almost no cloud cover at all, next to the near persistent cloud cover of the ITCZ. This is due to the descending node of a circulation pattern called the Hadley cell. You can also see that the poles are very cloudy over winter months. So during July, August, and September, you have high cloud cover values over Antarctica, whereas in December, January, and February, you have high cloud cover values over the Arctic. These values of high cloud cover are also associated with values of high precipitation. So if we change our climate property to total precipitation, we can see how these are associated with each other. So over the course of the year, you can see that this area of the highest precipitation moves from the south to the north, which is associated with the ITCZ. Areas of very little precipitation over the course of the year include the Saharan Desert and Saudi Arabia, which are present here and here. Another notable feature in precipitation maps is the lack of precipitation over Antarctica, which we can better view by going and viewing over the South Pole. As you can see, the precipitation rates over Antarctica are most similar to those as we have seen prior over Saudi Arabia and the Sahara, which can classify Antarctica as a very cold desert. So, from these images of cloud cover and precipitation, we can determine the wettest and driest areas of the globe as well as they change over the course of a year. We can use this understanding of their formation to look at how these change with other modeling experiments and then determine that if rainfall increases in the tropics, we must be increasing the strength of the ITCZ in some way or changing its location. These are the ways that we expect you to interpret the charts from Build Your Own Earth. Thank you very much for your attention, and happy exploring.